Welcome to the United States Sports Academy, America's Sports University. This is Unit 4 of Math 465, Statistical Measurements in Sports. This unit presents topics covering the measures of variability and the normal curve. It is important to note that this presentation is simply a summary of the topics covered in Unit 4 and not intended to replace the textbook or any supplemental readings.
Welcome to Unit 4 of Statistical Measurements in Sports. This unit focuses on the measures of variability as well as the normal curve. Now, in this unit, you will learn about the four main measures of variability, which are range, which you should already be familiar with, interquartile range, variance, and standard deviation. Now, when we're talking about variance and standard deviation, those are two very important terms that you want to become very familiar with, especially as you run more sophisticated tests as you progress in this course. You will also learn about the basics of probability in this course, which will prove to be valuable for you on down the road. If you have any questions, any concerns, please by all means reach out to your instructor. Thank you.
Slide 4, Unit Learning Objectives. After successfully completing this unit, you should be able to 1. Calculate the main measures of variability. 2. Convert raw scores into standard scores. 3. Understand the concepts of probability and odds. 4. Calculate skewness and kurtosis. Variability is a measure of the spread, or dispersion, of a set of data. Most statisticians recognize four main measures of variability: range, interquartile range, variance, and standard deviation. The range is simply the numerical distance from the highest to the lowest score. It is a quick estimate that can be made of the variability of the data. It is easily calculated, but it is only a very rough measure. The interquartile range is the range in raw score units from the 25th percentile to the 75th percentile. The interquartile range is a useful measure of the spread of data if the researcher is more interested in the middle scores than in the extremes. Both the range and the interquartile range consider only 2 points of data in determining variability. Other measures of variability are variance and standard deviation. Variance is the average of the squared deviations from the mean. Standard deviation is the square root of the average of the squared deviations from the mean. When the sample size is large and the distribution is close to normal, there are usually 5 or 6 standard deviations within the range of a dataset. In other words, there are about 3 standard deviations from the mean to the largest score and from the mean to the smallest score. You can see this illustrated in the figure. If the sample size is too small or skewed, the rule does not hold. Slide 7.
In this lecture, I'm going to talk about the normal curve and the empirical rule. So in the past, I've used bar graphs to display discrete data, like the graph below, and I've used histograms to display continuous data, like the graph below. You can see that the difference between a bar graph and a histogram is really whether or not the bars are touching or not. So the distributions of many or most continuous variables will ideally follow the shape of the normal curve. Now the normal curve looks something like this. Now I'm going to label it where on the bottom we have values, and then on the y-axis we have the different probabilities associated with those values. So I'm just going to make up some numbers here. You can see that 4 has the highest probability, that's in the middle. So those are some values I made up. And in this graph, in a normal curve, a perfectly normal curve, the mean, median, and mode all exist at the center. So for this curve, 4 is the mean, median, and the mode. Remember, those are measures of central tendency. So below the mean, median, and mode, 50% of the scores lie, and above it, 50% of scores lie, because it is exactly in the middle of the distribution. So the graph changes direction at inflection points. In these inflection points, when you're one inflection point from the mean, it marks one standard deviation from the mean. So I'm just going to draw some lines here to mark the standard deviations. So for like 3 and 5, if you're at those, you are 1 standard deviation away from the mean. If you're at, say, 2 or 6, you are 2 standard deviations away from the mean. So now I've marked that on the bottom, where we have the mean on the bottom, and then you can see as we're going up 1, 2 standard deviations, and down 1, 2 standard deviations. So now the empirical rule. The empirical rule states that 68% of all the values in your distribution will fall within 1 standard deviation of the mean. So for this distribution, you would expect 68% of all the values to be between 3 and 5. Now it also states that 95% of the values will fall between 2 standard deviations of the mean. So we would expect 95% of values to lie between 2 and 6 for this distribution. And while I don't have it marked on my graph, also another part of the empirical rule is that 99.7% of all values will fall within 3 standard deviations of the mean. So almost all the values will always be within 3 standard deviations of the mean. If something is outside of that, it'd be a very rare event, right? Because it's very unlikely for something to be outside of 3 standard deviations. So I'm going to take that off, and I'm going to put in these probabilities. Realize that using what I just taught you, we can actually figure out the probabilities that lie within these areas. Like, for example, we know half the scores have to be below 4 and half the scores have to be above 5. We know that 68% of the scores are between 3 and 5, so I'm just evenly splitting that up into 34 by 34. So using this empirical rule, we can actually find out what area is associated between different distances without doing, things like complicated calculus, which we could do, but it would be a lot of work for every distribution we have to work with. And that is the normal curve in the empirical rule, which you construct for continuous random.
Standard scores are scores that are derived from raw data and have a standard basis for comparison. To make an appropriate comparison, raw scores must be converted to one of the 4 standard scores: percentiles, z-scores, t-scores, or stanines. The figure shows the relationship among z-scores, percentiles, and t-scores on a normal curve. Be sure to study z-scores, t-scores, and stanines more in detail.
With this lecture, I'm going to start off with the very basics of probability, and then eventually we'll move up to some more advanced concepts. So first of all, probability. What is probability? Well, probability is a measure of the likelihood of an event. Like, for example, if I flip a coin, what's the probability of the coin landing on tails? Well, there's a way we can write this. Probability is the number of ways an event can occur divided by the number of possible outcomes. So I'm going to move that up there. Now, a sample space is a collection of all possible outcomes. So imagine if you were to flip a coin, you could either get heads or tails. So your sample space is heads and tails. So the probability of getting tails is 1 divided by 2, because there are 2 different outcomes and one of them is tails. So 1 divided by 2 is 0.50 or 50%. There's a 50% chance that when you flip a coin, you will get tails. So probabilities will always be between 0 and 1, 0 being a 0% chance and 1 being a 100% chance. If you get a number like 1.2 or -3, that's wrong. It always has to be between 0 and 1. An event with a probability of 0 is impossible, as in it will never occur. And an event with a probability of 1 is certain, as in it will always occur. And that's the basics of probability. Understand what a sample space is, that it's just a list of all possible outcomes, and know what it means for something to be impossible and for something to be certain.
Let's review.